So in today's lesson, we're going to talk about lesson number 2, stoichiometry calculations. Now the big idea is we use coefficients relate reactants and products so we can perform mole calculations. So we're going to apply what we learned in our previous lesson in how to apply molar calculations with mole ratios. And we're going to expand on that with now applying it with our mole concept. So what do we have to do? Well, we all know that mole ratios allow us to relate between different types of chemicals. So mole ratios, the molar ratio relates different chemicals. Now we can call this mole ratio a different name. We actually have a name for it that's a lot of people use. It's called mole bridge, in that it bridges your different chemicals. Now if you go to page 125 of your Hebden, you will see this mole bridge in action. You're going to see that as long as we have a starting value, we can cross what we call the mole bridge to get to the other value. Now this is another version of this mole bridge. So as you see, if we have some, for example, some mass given, we can use molar mass to get to moles, cross our mole ratio to get to the other chemical, and then solve for any of the three variables we have. Same with volume, and same with molecules given. So we have this mole bridge, we call it right here, which uses the mole ratio because it bridges. You could also think of it as if I were to put a box around it, this is your mole concept in one side. You're basically trying to relate two different mole concepts together to help you solve for your different chemicals. So what do you do to help you solve with the mole bridge? The strategies we're going to use to help us solve are pretty straightforward. What you should always have is, you should always, for step number 1, you should always have a balanced chemical reaction. Now why you should have a balanced chemical reaction is because you need to have your coefficients in place to help you convert. Now what do you do next? Your next step is now to, from your starting value, and this starting value can be in mass, it can be volume, and it can be particles. You want to, from your starting value, convert to moles. So from the starting value, you now convert to moles. What do you do in step 3? You want to now convert your moles of what you just started and convert to your what you want to solve for. So you want to now cross the mole bridge using the molar ratio. And your last step now is to convert your moles to final value, which can be, for example, your mass again, your volume, or your particles. Okay, so these are the 4 steps you gotta use to help you solve for your concepts of stoichiometry calculations. So let's apply these 4 steps in our calculations. So let's look at example number 3. In example number 3, you have a reaction. 2 KCl3 will decompose into 2 KCl plus 3 oxygen gas. So if you're given 1.5 moles of KCl3 and it decomposes, how many grams of O2 will you produce? Well, you're given 1.50 moles of KClO3. So So you're getting this chemical right now, and you want to get to oxygen. So you got to cross the mole bridge because your units are already in moles. So you already did step one, because step one is just making sure you have a balanced reaction. Step two is to convert whatever to moles. So that's already done. You already did step one and step two. Step three is to cross the mole bridge. So you want to now cross the mole bridge. So you were at moles of KCl3, and you now want to get to moles of oxygen. So the mole ratio there ends up being 3 moles of O2 over 2 moles of KClO3. And as you see here, your moles of KCl3 cancel each other out. Your last step is now to get to grams of O2. So you're now going to multiply your moles of O2, looking at your mole bridge. You now are here. You want to get to here. So you got to use the molar mass of O2. So what is the molar mass of O2? Well, if each oxygen is 16 grams, if each oxygen is 16 grams, if you have O2, that's 32.0 grams per 1 mole of O2. So here you see that moles of O2 will cancel, and you're left with your final value you want to solve, which is grams. So if I punch this all into my calculator, you would see that I have 1.5 moles of KClO3 times 3 moles of O2 divided by 2 moles of KClO3 times 32.0 grams of oxygen, and you get 72 grams. But you gotta make sure your answer is in 3 sig figs, so it becomes 72.0 grams of O2 will be produced. So this is how you can now convert from KCl3 into something else, another chemical, using your mole ratio. So again, if you want to pause this video and solve for your your next question, you can practice that first. So let's look at our next question. If 121.0 liters of O2 is produced, how many moles of KClO3 were decomposed at STP? So now you have STP involved, which means you can use 22.7. So you have 121.0 liters of O2. Your first step, you want to now convert so you already have your balance equation, so step one's already done. Your balance equation is still the same. But now from your starting value, which we have in volumes, convert to moles. So you want to convert this liters to moles. So you have to go from your STP, which is 1 mole of O2, and it's 22.7 liters. So as you see, your liters cancels out. Now our next step is now to cross your mole bridge. What is the mole ratio again from O2 to KClO3? From your balance equation, it's 2 moles and 3 moles. So for every 2 moles of KClO3, you have 3 moles of O2. So 2 moles KClO3 over 3 moles of O2. And we want to solve for how many moles. This is how we did it, because the moles will cancel out. So now again, you want to punch this into your calculator. You would see that you have 121 divided by 22.7 times 2 divided by 3. And you're going to get 3.554. 4 sig figs. This answer should have 4 sig figs, so it becomes 3.554. That 3 rounds up because of the 597 afterwards. So it becomes 3.554 moles of KClO3. So if I were to do the next question, you can actually pause the video again and practice this next question, but I'm going to move on to this one, which is we want to produce 2.75 moles of KCl. How many particles of KClO3 would be required? So you want to produce 2.75 moles of KCl. So you're at moles now. That is step number 2. You want to convert to moles. Step 3 is to use the molar ratio of KCl and KCl3 to convert to this substance now. So what is the mole ratio again? This time it's 2 moles to 2 moles of KCl. So you want to now write 2 moles of KClO3 to 2 moles of KCl. So we're now just left the species of KCl, and we're now in the species of KCl3. Our last step is now to find particles. How do you always find particles? It is using Avogadro's number. So Avogadro's number is 6.02 times 10 to the 23 particles over 1 mole of KCl3. As you see here, our moles cancels out. So we're left with just particles. So again, we punch this in our calculator, and we see that 2.75 divided by 2 times by 2 gives us 2.75 still, times by 6.02 times 10 to the power of 23. And we get this large number. Now if you can't read this number is 1.66 because of 3 suffix. 1.66 times 10 to the power of 24 particles. So because it's 3 sig figs from 2.75. So now we're going to try example number 4, which is how many liters, so we're going to solve for liters, of chlorine gas at STP can be liberated, which means collected, from the decomposition of 64 grams of gold chloride. In this case, gold 3 chloride. So here's our bounce reaction. That's our bounce reaction right there. So what we have is we have our starting value, which is 64.0 grams of gold. So we have that one gold. And we want to solve for chlorine. So we're going to turn gold chloride into chlorine gas. Our first step, you got to solve your starting value into moles. So we want to go from grams to moles, which means we got to use the molar mass. What is the molar mass of gold 3 chloride? So if I look at this and I see gold, gold has a molar mass of 197. So I add 197 plus 3 chlorines, which means I go 3 times 35.5, close bracket, and I equal, the total molar mass here is 303.5. So 303.5 grams. That is the molar mass of gold chloride. Now notice I don't multiply this number by 2. Some students will usually multiply this number by 2, but this 2 here is just a coefficient used for the molar ratio. So do not take 303.5 and multiply by 2 because you think that I had to multiply this by 2 from the coefficient. You don't. So this now is moles of AuCl3. Now I want to cross the mole bridge because now I'm in step number 3, which is cross the mole bridge from my gold 3 chloride to chlorine gas. My mole ratio here ends up being 3 moles of chlorine gas over 2 moles of AuCl3. And as you see, your moles of AuCl3 will cancel each other out. Now, our last step, we're now in moles of Cl2. You now want to get to liters STP. STP again is 22.7 liters per 1 mole of Cl2. And right here, you cancel your moles Cl2, you're left with just your liters. So if I plug this into my calculator, I will see that how many liters do I get from the decomposition of 64.0 grams of gold 3 chloride? 64 divided by 303.5 times 3 divided by 2 times 22 point, oops, I messed up. 64 divided by 303.5 times 2 divided by, oops, I messed up again. Tiny little calculator later. Divided by 303.5 times 3 divided by 2 times 22.7. And I will get 7.18. So 7.18 liters. So now if I double check this number to make sure I have it correct, again 64 divided by 303.5 times 3 divided by 2 and times 22.7. I should get 7.18 liters of chlorine gas will be collected. So it's chlorine gas. So again, if you want to pause the video anytime to practice the next few questions, you can. But I'll move on to the next example, which is example number 5, and then finish off with example number 6 so that we can finish up today's lesson. Now example number 5 is calculate the mass of silver chloride that can be prepared from 200 grams of aluminum chloride. Okay, so that means you want to solve for this, and you're given this. So you want to go from this value to that value. So in this case, you start off with your 200 grams of aluminum chloride. And you want to get to your moles of aluminum chloride using molar mass. So what is the molar mass of aluminum chloride? Well, you can see that chlorine again is 35.5. I have 3 of them. And I add that to aluminum, which is 27. My molar mass ends up being 133.5. 133.5 grams. So my grams will cancel out, and now I'm at moles of aluminum chloride. I now got to cross the mole bridge. There's 1 mole of aluminum chloride per 3 moles of silver chloride. So that means I put 3 moles of silver chloride over 1 mole of aluminum chloride. So as you see here, our moles of aluminum chloride cancels out. My last step is to now convert my moles of silver chloride into mass of silver chloride. So mass of silver chloride, again, based on our periodic table, mass of silver chloride, as you can see, silver is right here, 107.9 plus 35.5. And I should get a mass of 143.4. So 143.4 grams over 1 mole of silver chloride. And that should cancel my moles of silver chloride. So now I could punch all these values into my calculator because I just solved for my mass that I'm trying to solve for of silver chloride. So what I get here is I get 200 divided by 133.5 times 3 times 143.4. And I should get a value of 644.5 because I should have 5 sig figs. So 644.5 grams of silver chloride. So we went from our mass of aluminum chloride to moles of aluminum chloride to the mole ratio to get to silver chloride. And then lastly, we find the mass of silver chloride. So we'll finish up today's lesson on the last example, which is how many atoms of sodium are required to completely react 75 liters of chlorine gas at STP. So you're currently in this species, and you want to solve to that species, and we find atoms of sodium. So 75.0 liters of chlorine. How do we solve to moles of chlorine? Well, we got to use STP, which means 1 mole of chlorine is equal to 22.7 liters of chlorine. So liters will cancel each other out. So now I'm at chlorine, I got to get to sodium, which means I got to cross the mole bridge using the mole ratio. The mole ratio is 2 moles of sodium is equal to 1 mole of chlorine gas. So my moles of chlorine gas will now cancel out. My last step is to get to atoms of sodium, because this sodium here is an atom. It's an element. It's not a compound. My Avogadro's number is representing the atom of sodium. So 6.02 times 10 to the 23 atoms per 1 mole of sodium. And that, again, will cancel my moles of sodium. So I'm left with this value of 6.02 times 10 to 23 atoms, and I can now calculate all my values. So 75 divided by 22.7 times 2 times 6.02 times 10 to the power of 23. And I should get 1, 2, 3, 4, 5, 6, 7, 8. I should get 3.9. 3.98. Oops. 3.98 times 10 to the 24 atoms of sodium. Now remember, the reason why I'm putting 3.98 is because it's 3 sig figs, and my calculator can round thus to 3 sig figs. So this is today's lesson on how to use stoichiometric calculations. Now your homework is page 127, number 6 to 16 even. Now that means you're doing number 6, number 8, number 10, number 12, number 14, number 16. And some of the questions have multiple questions in them. But this means that you get extra practice to help you solve. Now, as always, stay safe and healthy, and I'll see you next time.